Hey kids, now we're going to do a lab, but first, there's my friend Teddy. He's waiting for a piece of bread. He's very excited about it. And the bread maker, Mr. Bush,
Hello.
is right there. Okay, so we're going to do a lab. What you're going to do is go to this page. Describes the lab. Page 9 is where we're going to put our data, but first we have to do the lab. So watch carefully for the lab. Welcome to Crazy Labs with Mama Bush. All right, for this lab, we are going to take this piece of metal, and find its mass, and its mass, oh look, 100 grams. Write it down. Now we're going to put it in to the pan to heat up. And we're going to find the mass of the water in the cup. And the mass of the water in the cup is 24.5 grams. Okay? Now we're going to take the temperature of our metal. And our temperature of our metal is 110 degrees. And we're going to take the temperature of our water, and the temperature of the water is 20 degrees. Oh, I didn't put it in there. Now it's 20 degrees. And then we're going to dump our mysterious metal in. And we're going to take our temperature. And I don't have a piece of paper, so we're going to pretend like it says 35 degrees. All right, now that we have our lab data, let us calculate. All right, the mass of our water is 24.5 grams. The initial temperature of our water, all right, so the mass of the water was 24.5 degrees. The initial temperature of the water was 24.5 grams, 20 degrees Celsius. The final temperature was 35 degrees Celsius. The metal was 100 grams to begin with. The initial temperature was 110, and the final temperature was 35. So, what was the temperature change? Let's do that first. The water had a temperature change of 15 degrees. The metal had a temperature change of 85 degrees. But the temperature went down with the metal, so we're going to put a negative there. The specific heat of water is 4.184 joules per grams degrees Celsius, and we're going to solve for the specific heat of the metal. All right, the first question, which is exothermic? Who's losing the heat? The metal. And that means that the water is gaining the heat. Calculate the specific heat of the metal. So we're going to use Q equals MCAT. This side is going to be the Q of the water. This side is going to be the Q of the metal. All right, so we're going to do this here where we have more space. Q of the water is going to be equal, got water gained energy, so it's positive. The metal lost energy, so it's negative. All right, we're going to do MCAT equals MCAT. The mass of our water was 24.5 grams. We know the specific heat of water is 4.184 joules over grams degrees Celsius, and our temperature change was 15. that is going to be equal to the mass of the metal, which was 100 grams, times the metal change, which was a negative 85 degrees Celsius, times the specific heat of the metal. All right. If we solve for the specific heat of the metal, we end up with 0.422 joules over grams degrees Celsius. Now, what specific heat is that? Well, iron happens to be 0.45 joules over grams degrees Celsius, which is on like the second page of the lab, but it's not there. We worked out of a different problem like that, so we know that we're going to assume that this is iron. All right, so that is how we do this lab. You don't need to do all that stuff, the notes, but let's go ahead and do some problems with calculating Calfee cup calorimetry. All right, so we're working some Calfee cup calorimetry problems now. Just like the lab, the fake lab we just did. A piece of lead is heated to 120 degrees. It's added to a cup of water that has a mass of 30 degrees and is at a temperature of 20 degrees. Find the final temperature of the water, and the metal is 40. What is the mass of the metal? So again, we're using the negative, well, no, not negative. The water, the heat of the water is equal to the negative heat of the metal. All right, so first we have to do Q of the water. We need the mass of the water. The mass of the water is 30 grams. We need the specific heat of the water, 4.184. We need the temperature change. The water started out at 20, ended at 40, so we have a temperature change of 20 degrees. We're going to solve for the mass of the lead. So the metal mass is what we don't know. The specific heat capacity of the metal is 0.128 joules over grams degrees Celsius. And our temperature change for our metal was 120 to 40. So 40 minus 120 would be 80 degrees. Now I solve for the mass. Okay, there's two more problems here. This one's also solving for mass of the metal, and this is solving for delta T of the aluminum. All right, you don't need, it tells you the delta T of the water. You don't need to calculate, or you're just going to calculate delta T. You don't have to have a starting and ending water temperature and aluminum temperature. Okay, all right.